All right, part two of our discussion of DeWitt's chapter 27 on interpretations of quantum mechanics. We left off having just discussed the famous Schrodinger's cat thought experiment, which was initially supposed to be an argument for a kind of realist or hidden variable view. Those views argue for the incompleteness of standard or Copenhagen interpretations. Einstein is the most famous defender of hidden variable views. We'll talk about his stuff a little bit today, and in our last lecture on quantum, we'll go deeply into Einstein's view. So the standard or Copenhagen view, these are also called collapse interpretations by DeWitt, is at the empiricist or instrumentalist end of things. The math works, let's not worry too much about the details of a physical interpretation of the math beyond what it takes to get accurate predictions. It's interestingly ironic that Einstein is the main opponent of views like this because Niels Bohr is the main proponent of Copenhagen views. Einstein was his hero until they started fighting about quantum mechanics anyway. Special relativity is the inspiration for this idea that reality does not outrun the possibility of measurement. So Einstein said you don't mean anything by asking whether two events are simultaneous or not if they occur in different reference frames. It's a bad question because there is no measurement corresponding to the time at which the event happens in no reference frame in particular. So Einstein says people were unable to appreciate the truth of special relativity because they thought there was a fact about, for instance, when events occur that was independent of reference frames. And there aren't any facts answering to that because they are, in principle, impossible to measure, so they're not scientific facts. Bohr says to Einstein, I'm doing exactly what you did. What I'm saying is it's meaningless to ask whether there really is a superposition, this idea that you want to put italics under really. For empiricist-minded scientists and philosophers, that is always a suggestion that you're committing metaphysics rather than sticking with physics. So Bohr says there is no measurement, right? A measurement would collapse the wave function. So you cannot experimentally detect the superposition itself. You cannot talk about the position and momentum and spin of an electron apart from our ability to measure such things. So we can talk about some probabilities of what we would measure were we to perform a measurement. But to ask where the particle really is or what momentum it really has apart from any measurement operation is to do metaphysics rather than physics. So Bohr basically says asking where the electron was before we determined its location by bouncing something off of it is like asking what color the number 4 is. It is a meaningless question. So we have to resist giving in to our need to picture the underlying reality. The realist intuition is you've got this lovely wave math, and so you want to say, well, there's really a wave prior to turning on the detector. Bohr says you should not say such things. You should say, here's what will happen if we don't turn on the detector. Here's what will happen if we do turn on the detector. And that's all there is. To ask what's really going on when we're not observing things is neurotic, Bohr thinks. Seek therapy rather than physics for this. You want to feel like you understand what's going on, but science won't be able to answer questions about what would happen if there were no measurement. So even though Einstein's special relativity is the inspiration for Bohr here, Einstein rejected the application of his reality doesn't outrun measurement idea to quantum theory. Quantum complementarity is a fairly famous aspect of it that we can deal with pretty briefly. Bohr suggests that you can have a wave-like conception in mind and get certain kinds of information under wave-like setups. You can have a particle-like framework and get certain kinds of information about particle-like features of the system. But either way, there will be aspects of the system that you cannot get information about, and you can't answer the question, what's really going on? So Bohr denies that that question is even a meaningful question, right? It's not just that we we can't in fact answer that question. Bohr denies that it's a question. What color is the number 4 is not a legitimate question. You should get over your need to have an answer to it. What is really going on behind the scenes of a quantum setup is a question that Bohr thinks you need to get over. So again, Bohr invokes Einstein in debates with Einstein, just as time and length values can be attributed to things only relative to an experimental setup that specifies the motion of reference frames with respect to one another, for instance. Properties can be attributed to a quantum system only relative to the choice of a particle-type experimental setup or a wave-like experimental setup. So DeWitt, I think, does a nice job of bringing out part of Bohr's view, that there's nothing to know, not just our inability to know it. But for Bohr, it does, I think, go deeper than that, which is it is meaningless to ask these questions. They are not meaningful questions that we are, in fact, unable to answer. They are scientifically meaningless questions. All right, I'll keep this one short, and then I'll close out with one more lecture on this material. Thanks as always.